So College Algebra 5.1a, and the name of this brand new chapter is Systems of Equations and Matrices. And for the most part, what we're going to be doing in this section is just some systems of equations that you have already learned how to do. The elimination method, substitution method, and then the third one is solution by graphing. And what we've got here is we've got two equations, such as this, and I just want to explain kind of what's going on here. This stuff was never explained to me. It's kind of like, okay, here's how you do it, but I had no idea why I was doing it or what the whole purpose behind the answer I got was all about. So hopefully I can help you with that. So we have two equations, okay? Alright, so when I find out what the x value is for these two equations, in fact the x value is 2 and the y value is negative 3. And what that means is that if I put 2 and negative 3 in here, it makes this a true statement. If I put 2 and negative 3 here, it makes this a true statement. So this answer here makes both of these equations true. So x and y, 2, negative 3 work here, and they work here. And because they work in both of these equations, then when I graph these two equations, what happens is they cross. The point they have in common would be 2, negative 3. Okay? So this is the point that both of these graphs, the graph of these two equations, have in common with each other. Alright, so we have three different options for answers. They either cross in one point, they cross in no points because both equations are parallel to each other, or they cross like when you draw one, the other one lies on top of the other one, which means the lines are the same, the lines are identical. So this one has 1 point in common, this one has no points in common, and this one has all points in common, infinite points in common. Okay, so those are your three different options there for an answer. So if you are solving a system of equations, and the first thing they do is they say, if you solve this graphically, pretty much what you're going to be doing is you're going to be making your xy axis. You're going to plug numbers in here for x, it's going to spit out y's for this equation, and then you're going to have an x and a y, put in an x, put in a y for this equation. And where those two equations cross is going to be your answer. The problem with this is this one right here isn't so terrible because you can look and go, oh, it crosses at 2, negative 3. But what if it crosses in between, say, 1 and 2? So let's say that you've got a graph here and you've got 1, 2, 3, and you draw your line and it crosses maybe right there. Well, where is that? You can only guess that it's like, maybe it's over 1.5 and up 1.5, maybe 1.6, not really sure exactly. This is just used to kind of estimate where the point is going to be. You can't get an exact value, especially when you're in decimals. And that's why we're going to do elimination and substitution, is that way you can get exact values for your x and y. Alright, so that's graphically. You just make the table for each equation, graph 3 points, and go from there. And right now, one of the things that's important to realize is we're doing linear equations. We're doing two straight lines and where they cross, if they cross. Later on, we'll be doing something like, you've got a graph here, you might have a parabola, and then a circle. And then they cross in two places, so you have two answers. So we'll get to that later. But right now, we've just got exponents of 1 on each of the x and the y, which makes them linear, and it makes it a lot easier to graph. So middle of page 435, there's some vocabulary I would write down. I don't really bring this in a whole lot because we really don't use it a whole ton, but I want to at least bring it in there. If a system of equations has at least one solution, so you have two lines and they cross at one point, it is called consistent. Okay? If the system has no solutions, if it's parallel, it's called inconsistent. Okay? If a system of two linear equations and two variables has an infinite number of solutions, so they're on top of each other, okay, the equations are dependent. Okay, so what we've got here is, and if they are not on top of each other, they're called independent. Okay, so independent solutions only work when there are no points or there is one point. Dependent is when there are an infinite number of solutions. Okay, when they're on top of each other. So if you have an equation that is consistent, that means that it has at least one point. So this one's consistent. But because this one is on top of each other, it has at least one point. Not one point as a solution as an infinite. It's not only consistent, it's also dependent because it has an infinite number of solutions. So a couple of these can have consistent and dependent at the same time. So anyway, just get those down in your notes. I don't really necessarily use them, but in some of your questions for the homework, they may ask you, is this consistent? Is it independent? Is it inconsistent? Etc. So just make sure you get those down in your notes. Okay, so this is example 2, and we're going to use substitution method. We're going to use that first, and then we'll get into elimination. And again, we're just going to do one problem over this. One of the things, you can solve these systems of equations where you have 2, 3, 4 equations, and you're trying to find out what they have in common. You can do those using either substitution or elimination. You're going to get the right answer regardless. Substitution oftentimes is an easier method, and it works best when one of the equations is rather simple. Okay, if they're both very complicated, you can still use substitution, but elimination is usually a better direction to go. So again, this equation is fairly simple because what you're going to do is you're going to take the simplest equation and set it equal to one of the variables. It does not matter which one. You could say x equals 5 plus y, or you could say negative y equals 5 minus x, and then change the sign to that. So you could use this, or you could use this. It doesn't matter. But then again, this one was the simpler way, and this one was the more complex way. So if you decide to go with the simpler way, x equals 5 plus y, then life is a little bit easier. So what do we do with this x equals 5 plus y? We look at this equation right here, and wherever we see an x, since x equals 5 plus y, we put in a 5 plus y. And it would have helped if I wrote the equation right. The second equation should have been 2x plus y. And then we can put in a plus y equals 1. Alright, so the reason we substituted is this is two variables. You cannot solve an equation that has two variables. The only thing you can do is if you have two variables, you have to have two equations in order to solve it. And that's what we're doing. We have two equations with two variables, so therefore we can solve it. So we have to solve one variable at a time. So we put in, we changed our x to a 5 plus y, so now we can put it here, and now we have one variable, a y, and one equation, and we can solve it. And we have 10 plus 2y plus y equals 1. Go ahead and solve that, and you end up with a y equals negative 3. Now I'm going to solve that for you. Your college algebra, you know how to do that. Alright, so y equals negative 3. Now we take that either equation, but usually the simplest one, and put our negative 3 in there. So, and we get x equals 2. So therefore, the point where both of those lines cross each other is the point 2, negative 3. Okay? So how do you know if it's parallel, or how do you know if it's one line's on top of the other? Well, you won't get simple solutions like this if the lines are on top of each other or they're parallel. And we'll get to some of those in a minute. But if you get 2 points, no problems at all, then they cross at one point, just like that. Alright, let's jump to the elimination method. And again, if this is like, oh my gosh, I know how to do this, we've been doing this for years, it's just an intro to matrices, so just take it as that. Alright, so we're going to do elimination. Now again, this one is a very simple problem, and it would probably be easier to do substitution because we can just make this as x equals 7 plus y and substitute and be good. But teaching you elimination is important. So, if you remember, draw a line there, and we're trying to eliminate one of the variables. It doesn't matter which one. But in order to eliminate them, one of the variables has to be positive and one has to be negative, because what we're going to do is we're going to add them. So in this case, we're going to get 2x plus x. We add these, we get 0. We add these, we get 9. X equals 3. And we just found out what our x value is. We can take that 3, plug it into either one of these equations, doesn't matter, and we find our y value, and we find that that's negative 4. So 3, negative 4 is our answer, and that's where both of these equations cross. Okay? Alright, so we're going to stop this video and go with 5.1b as we start example number 4.